Okay, let us continue with the next session. Here, whether Anant is there?
Yes, ma'am.
Yes, you are there. So we will begin with Anand's session on UDP, and then we will continue with one example programming. Okay. Uh, Anand, how long it will take?
Not more than 10 minutes, ma'am. I'll
Okay,
finish it off
fine.
as soon as I can.
Yes, you can take your own time. 15 minutes, within 15 minutes, you try to finish it off. Okay?
Okay, ma'am. Yeah.
Yeah, let's begin.
Okay. Hi guys. My name is Anant, and today I'll be talking about user datagram protocol. So, user datagram protocol or UDP is a much simpler and faster method of doing pretty much the same thing that TCP does. So, first, let me talk about TCP. We all know, as Ankit just spoke right now, that with TCP, there's first a three-way handshake that takes place. So the client requests the connection and the server confirms it. And after that, any data processing can take place. Now you'll notice that some of these lines are diagonal. The reason I've made these lines diagonal is because I want to show that these lines, or rather these processes, they take some time, right? So when this TCP, it makes sense when I want to when I want to load a website. When I have a website and I want to access a website, it makes sense because I don't want any packets to be lost, right? I don't want my website to be half seen. For example, if this is my website and this entire part isn't seen, this half of this website isn't seen, then it's an issue. So none of the packets can be lost in TCP. That's why there is very stringent error checking, this packet delay, and all of that. But in UDP, which is used in real-time, applications like gaming, video conferences like this one, so you'll notice that when you are taking part in a real-time application, there is something called as ping and there's something called as packet loss. So ping is basically the latency between you and the server, between the client and the server. So that's basically how long is it taking. For example, if you are committing a packet or you're sending a packet, how long is it taking for the server to get the packet? That is ping. And most generally, it is in the range of 20 to 150 milliseconds. That is fine. That is an acceptable range of ping. The more important thing is packet loss, right? So because in UDP, there is no checking. As you can see, there's no confirmation of connection. There's no request. There's just request data, send data, request data, send data. So because there's no server, there's no checking of packets. There's no checking if, all the 100 packets that have been sent have been received. There is a certain amount of packet loss in some cases. Now, that is an issue in websites, but in real-time connections where speed is of more importance than complete connection, complete data being sent, we use UDP over there. So the advantages of UDP is, as in TCP, it takes 20 bytes of header in each packet, whereas in UDP, you only have 8 bytes. And because there's no connection checking, there's no, checking of how many packets have been received, it's much faster as far as your entire latency is concerned. And the only drawback is that there is some packet loss, which, as I said, is not acceptable in a static application like a website, but is pretty acceptable as long as the loss is between 1 to 2% in in a real-time application. Now, coming to the data flow diagram, so basically the server first opens the socket and then it names the socket. So socket and bind are the two functions that we use as network engineers. The client does the same thing. It opens the socket. Now, as you'll notice here, there's no authorization request, none of that. There's no there's no listen, right? It's just sending and receiving of data. And then when one of them is ready, they'll close the connection. So the proper diagram is over here. So socket, which is this part of the code, open the socket. Then it's bound to a port and given a particular name. So this is what bind does. It binds this particular socket to a particular port and it gives it a particular name. And then receive from. Now this receive from is similar to listen in TCP protocol. However, there's one difference over here. Once the server initiates receive from, this particular thread that's running. So there's unlimited number of threads which are similar to this that are running. Unlimited number of, not unlimited, but a high number of sockets and a high number of threads that are running. But this particular thread will be stopped until some data comes, right? So let's block this here and go into the client. Now the client does the same thing. As soon as you send some data, it creates a socket, it binds it to a particular variable and a port, and it sends the data. Now when the server receives the data, it processes it, does whatever it has to, And after sending, the client is waiting now. The client is set at receive from. Then when the server sends the data, this particular process is repeated until one of them closes the connection. Going into the code, I will explain it in a very simple way so that we don't waste too much time. Ma'am will take over the proper explanation of the code, I'm assuming. So let's look at it from this method. So first, the server needs to open a socket. So I have two codes here, udp.java and udp-client.java. So over here, I'm defining the server port or the service port to be 50001. As Ankit said, my ports are numbered from 1 to 65,535, and I can pick any of the ports as long as they're not being used by someone else right now. And as far as I know, 50001 is a very free socket or a free port rather. So over here, we need something called as datagram socket, which is provided to us in the java.net package. So datagram socket will allow us to create these sockets. That is this part of the code, open a socket. So this is where we're opening the socket, and it's got a constructor where we need to pass the service port, which is an integer. So that is what we're doing. I can also write this as 50001, but the reason we use service port is because in case we have 20 other sockets and by chance we need to change this port, we don't want to change it 20 times. So I'm just going to receive a data buffer of 1 kilobyte. So that's 1024 bytes. That's all I'm doing. So I have a receiving data buffer and a sending data buffer, which is 1 kilobyte long each. Now, as you can see, I create an input packet, right? And I wait for this. I just create an input packet, right? And after that, I do server socket.receive of input packet. So that is this. Let me just, yeah. So this receive from. So as you can see, I've commented here, this program halts here until it receives a packet of data from the client, right? So let's assume that the client has sent some data, right? So in this input packet, we'll have a lot of data. We'll have the we'll have the client's address, we'll have the data, we'll have all of that. So right now, I'm just taking the received data, and that is given to us by an inbuilt function called as get data. So we just print the data that is sent by the client. Now, what this server is doing is very simple. Whatever data it is receiving, it is converting it to uppercase and sending it back to the client. So that's what I'm doing here. So as you can see, sending data buffer is received data dot to uppercase dot get bytes. Why do I need get bytes? Because sending data buffer is a byte object. It's not a string. We can't be sending strings. When we are using UDP, we need to send byte streams back and forth to the client, as well as the server also only accept byte streams. So we need to use get bytes over here. Now, we also need the address of the server of the client. So that is available to us in this input packet that we've received from the client. So input packet, just the way we use get data to get the data, we use get address and get port to get the address and the port of the sender, or in our case, the client. So in this case, because I'll be running my server and my client in my same in my same system, my sender address will be 127.0.0.1, which is my home address or my local host, and 10231, which is the port address that I've defined in my client. And after that, I just create an output packet. The same way I've created an input packet over here, I create an output packet with the sending data buffer, which is that byte stream. Its length, because we need the data and the packet needs to know what length it is. The address of the sender, that is the address of the client, and the address of the port, right? And then I just send the packet. The same way I receive sender server socket.receive of input packet, I'm doing the same thing, server socket.send of output packet. And then I'm closing the, I'm closing the, I'm closing the connection right there. Now, if I don't want to close the connection, what I can do is I can, from this point, I can create a while true, right? And what I can do is in here somewhere, in here somewhere, I can create a break statement where I check for a particular condition. For example, if the client has sent the text by, then I can close the connection. So I can do that over there, and I can put this in a while true, and then it'll only close the connection after the sender sends by or the client sends by, right? And one very important thing, all of this is contingent on a lot of exceptions. All of these exceptions that any of these items can throw is covered under the umbrella of IO exception. That is why I'm using IO exception over here. It throws an IO exception and I'm catching it. And I'm only printing the stack trace right now, but we can check out the error code and print a, or rather send back a very, proper message to the client in case of connection failure or any of that. Now, when it comes to the client, I'm doing very similar things, right? So as you can see, there's not a lot of difference between the client and the server. So over here also, I'm doing very similar things. So over here, all I'm doing is, so we create the client socket, but you'll notice over here, we don't particularly uh, bind it to a port, right? Because over here, socket and bind, as you can notice, bind is optional because our computers will automatically bind it to an available port as soon as we send some data, right? So that is the reason. So here we're sending first, so we don't need to worry. But here we're receiving first. So that is why we need to bind it, right? So after that, I'm just getting the current localhost IP address. I'm creating the same sending data buffer, receiving data buffer, and I'm creating a normal string. You can take this from the user, but for now, I'm just creating a normal string and I'm using get bytes. Same thing over here. We're using get bytes. 1 second. Hello. Yeah. Am I audible?
Yes, you're
Okay.
audible.
So over here, I'm doing the same thing, just the way, in UDP, I'm, creating right here, receive data dot to uppercase dot get bytes to convert a string to a byte stream. That's the same thing I'm doing over here because I have to send this particular sentence. So I'm converting it into a byte stream and saving it in sending data buffer. Then I'm creating a sending packet, very similar stuff from what we've done in the server. I need this data buffer, I need the length, I need the IP address of the sender, and I need the service port, right? 1 second. So over here, my service port needs to be the service. My bad. Okay. So my over here it needs to be the service port of the server. So that is why I have 50001 over here. The same as the server. Now client socket dot send sending packet. So it sends the packet and over here it takes care of all of that as we've talked. So over here it receives it over here, it converts it to uppercase and it sends it back. Now when it receives it back, now datagram receiving packet, all of the same thing, right? And now we already have uh, the socket ready, right? So client socket dot receive receiving packet. So client socket is already bound to a particular, to a particular excuse me, to a particular port, and we don't need to bind it explicitly. Now, receive data, I'm doing the same thing, receiving packet dot get data. Here, I don't need to get the address or anything of the server because we already know it. We already have it in our, in our program. Uh, and then all I'm doing is I'm printing the data from the server. Now, I will share this program with the class. And what you guys need to do is you need to run it from your, you need to run the server end first and then run the client end, and you can see the output. That's it for my presentation. I'll just end with a small joke. So as we say, in UDP, we don't check for client, we don't check if the client has received all the packets. So this is basically a very common joke among network engineers where one of the engineer asks, you want to hear a funny UDP joke? And the others like, fine. And, the first guy is like, you may not get any of the data and I really won't care because that's how the server acts in UDP. Thank you so much.
Okay, uh, nice one, both Anant and Ankit. Um, so let us, probably I think Anant has shown a part of coding of UDP. First, let me just go through UDP program, sorry, TCP program, and then you will be, definitely I'll be asking you to modify the program for UDP on your own, okay? So let's just go to the programming part. As mentioned here, you have a socket, you have a bind, you have listen, you have a accept, okay, you have send, you have receive, and you have close the connection, okay. So these are available on the server part. So first thing, it has to start listening, okay. How it has to start listening? It has to create a channel through which it can start listening, and whatever request it receives, it has to send back with the response that is relevant to the request. So in doing so, there is a need for a channel creation, or there is a need for one way or two way channel creation. That one way or two way normally when I go ahead in normal client server application, we call it as full duplex. I think probably Ankit has covered about it. Full duplex talks about read write both has to be done. Now, so um, please let me know from your end. Do you want me to explain the different uh, functions that are available, or I will directly go with the program? Please let me know from your end. As and when the function appears, I will explain that function, or you want me to explain the function first and then come back to the program? What do you want? Please let me know from your end. With the program, the explanation, will that be okay? Okay, thank you. Prarthana has commented, you can explain it in the program itself. Thank you. Okay, so let me share the screen and I'll go to a simple example. Today you will have a lot of assignments, okay, based on the things that are being covered. Okay, are you able to see the screen? I'll just minimize this and drag it up. Okay, are you able to see the screen? I hope it is visible to you. I'll just go to the server part first. Okay. Here in this simple example, what I have done, uh, there is a client and there is a server, and server has started a socket by number with a port number 6000. It means that for this communication, the port assigned is 6000 and the kind of communication is full duplex. Okay, it means what? Server once has decided that this is the point from where I will be start listening to the client. The client can send the request and receive back the response from the server. So both are working in the same socket. That is 6000 is the port number that is been established. Just have a look at this. I think probably in yesterday's class I have covered this part. I'll just go back to this. Okay, I have covered this part in the yesterday's class, not yesterday, on Monday's class. What is this server socket class and what is this socket class and how they are different. So when I'm talking about creation of a new socket or establishing a fresh connection, I call server socket class in the server. Okay, and this server socket class, it accepts only one parameter that talks about what is the way, what is the port number upon which I have to start receiving the request from the client. Okay, now you have seen the diagram that is being shown by both Anant and Ankit. You have seen that there is a connection established, sorry, there is a call for the socket. Once the socket is ready, there is something called as bind and there is something called as listen. As soon as this object SS gets created with the number that is given, as soon as this line ends, server will be in what mode called as listen mode. That's what I was talking about. This is inbuilt or implicit function call. There will be implicit function call of listen. So whenever there is a call from the client, let me just explain it side by side so that you will understand it very clearly. Okay. Now you can just see in the client part, there is a use of socket class unlike in server which I have used server socket. Okay. Server socket accepts on what port you want to have. Okay. In the client, the socket constructor accepts two parameters. The first parameter talks about what is the host or what is the, uh, see, here I have given localhost. It is just because I want to run both client as well as server on the same standalone machine. If you want to have a connection established and the communication established between the two between the two hosts which are existing away from each other, then you can very well replace this local host by the IP address of the host with which you want to have the communication established. I have written localhost here because both client as well as server are running on the same machine on my machine. If suppose you are trying to create a client server scenario where I am acting as a host, acting as a client, and there is one more host sitting somewhere in the same CS department which is acting as a server, then definitely this inside this double quotes as a first parameter you pass the IP address of that host which you want to make it as the server. Are you getting this difference? If I write localhost, both the client and server are acting on the same standalone machine. If you want to have the communication established between the two different hosts which are available away from each other, then you give or pass the IP address of the host with which you want to connect. I hope this is clear for you. Can I proceed ahead?
Yes, ma'am.
Yeah, thank you. Now, the second part talks about, see, this number, whatever you have given in the client part, must match with the number that is given in the server. What if the numbers are differing? What if the numbers are differing? Can anybody comment on this? Will it make any difference if the number is differing? No guessing from your end? Even you can type it.
Ma'am, I think there'll be no connection only because the socket number is differing from the server number which we want to connect.
Okay. See, a single server can have n number of port numbers. A single server can have n number of port numbers. Each port number decides one kind of communication that is going on. So, at a time, there may be hundreds of clients working, and at a time, a server may throw n number of ports. The client has to decide to which port I need to get connected, so that what kind of communication you want to do, that decides this port number. So the port number, if it differs, definitely you are talking with some other port, so some other kind of communication is required at that port number. The port number must match in order to have a communication, the kind of communication that are needed. For example, even if you take FTP and TCP, okay, FTP has its own port number. If you choose that port number, that kind of communication will be established. If you choose telnet, that kind of communication will be established. Definitely the client must know to what port number of the server I have to get connected. Okay, over here I have exactly one client, exactly one server, and the server has decided that I have to throw the 6000 as the new port number for the next coming connection or the next kind of communication that is required. Okay, so whatever the number that is passed as the socket ID, that needs to be supplied as the second parameter on the client side. Okay, whether the first line of each of the code is clear for you. On the server side, it will just throw you the kind of the socket number upon which you want to work, it wishes to work on. On the other hand, on the client, it just tells I am trying to work on this particular port number with this particular IP address. Okay. Now, once this is done, once the client has created its own socket, it means that a client is ready to send the request. So what it does, what server does, it accepts the connection. It accepts the connection once the client has sent. Okay, so accepting of the connection definitely has to happen through the socket ID. And who holds this socket ID? The object that is created by the server socket constructor. Okay, so through this object of server socket, I have called the accept function, and this generates one socket. This generates one socket. Up to this point, what was it? It was just a listener. Up to this point, it was just a listener. In this part, in this line of code, listener has connected itself into the client which has requested for the socket of the number 6000. I hope this is clear. So the second line is for the acceptance of the connection from the client which has requested. Now, okay, before I could proceed ahead, there is something called as stream classes which talks about sending and receiving of data. Whenever you have a communication to be done between any two parties, be it local, be it locally local, be it global, however it is, any kind of communication takes place with what is called as a pipeline architecture called as stream. And a stream is of two categories. Either it can be input stream or it can be output stream. When it can be input stream, whenever I want to read something, I call it as input stream. Whenever I want to put something onto the network and so that reaches the other end, that is called as output stream. Since the server here over here is trying to receive a message from the client, what is the task of the server that I have written here? See, you can differ the way the server and the client are working, definitely. This is one such example. I have taken one simple example where server receives the data sent from the client and I am just printing what is being sent by the client. That's it. So what is the role of the server here? Role of the server is to read the data that is coming in from the client. So definitely I require what is called as input stream here. Okay. And I call it as data input stream. You have similarly file input stream. Okay. You have a simple input stream available. Okay. There are character streaming, there is byte streaming. Okay. Many ways of using input or output streams are there. Whichever is convenient for you, that you can use. Okay. I think you have buffered reader, you have buffered writer, you have buffered input stream, you have buffered output stream. So many options are there. I have used data input stream, data output stream. Okay, it's totally up to you what kind of input or output streams that you want to use. You can very well go with that. Java supports many streaming options available. Okay, among those I am using input and output streams. Now, since the server's role here is to receive the data, I am only declaring or I am only creating an object of data input stream. I do not want any data output stream. If suppose the client and server are working like this, client sends a message to the server, server receives it, processes it and sends back one more message. In this case, on the server end, I would require both input stream as well as output stream. As well, in the client side, I would require a both input stream as well as output stream. At this point, with this example, I have only server acting as input stream because it is only receiving the data from the client. So what should be there on the client side? Can anybody comment? What should be there on the client side? Server's role is reading the data that is coming in from the client. So what should be there on the client side?
Output
Yes.
stream.
Output stream. Definitely there has to be output stream. So accordingly, I will just map it. Data output stream, and I have created an object of that. New data output stream of, using the socket that is created, I will call a function called as get output stream. Similar to this, in the server side, I use a data input stream and create an object of that. Call a data input stream, and with reference to the socket ID that I have got, yes, after accepting the connection, okay, using that object I call get input stream. Are you able to map? On the server side, what I have done, I have called server socket with an ID and that creates an object. Using that object, I call accept once the client has created or sent its request for the connection to 6000. Okay, and once this is done, I will make sure whether server is only listening or receiving or it is also able to write. Based on that, we will create the streams. If it is only on the receiving end, that is, it is only reading the data, then I will go for only input stream. Otherwise, the server as well as the client would have got both the streams. In this example, server I am fixing only input stream. Okay. So this is definitely optional. This is definitely optional. I just want to print, look, I am server. Okay. Now, what is next on the client side? On the client side, I will just write, again, this is optional. Okay. This is just optional. What is that I have created is, I have created an object of data output stream. Using this object of data output stream, I will call a function which is called as a write UTF. Okay. You have multiple options of write function. Okay. You have write object, you have simple write, you have write UTF. All of these are doing the same thing of writing the data onto the stream that is created. Whichever function is convenient for you, that you can use. Okay. This write UTF, it mainly writes the data as a string only. Okay, not converts it into object format. So character streaming it is. Okay. You can either go for write UTF, you can go for write object, you can or go for write any kind of function that is okay with you, that you can use. Okay. Now, with reference to the object of output stream, I have called a function called write UTF. This, what it does, it just accepts only one parameter, asking for what you want to send on the network. What is that you want to send on the network? So right now I just want a hello server to be sent on the network. Okay. So in double quotes I have given because it's a string constant. Then on the server side, I will receive that. How does it receive? I have similar in synchronous with the write UTF, I have something called as read UTF, and I will use the input stream object to call that. Can I write a dout.read UTF? Definitely not, because dout is for the object which I have created for data output stream. Output stream cannot have read UTF. Input stream similarly cannot have write. Okay. Now, when I have called this read UTF, it will try to read from the stream that is available on which the client has sent the message, and I will convert that into string format. This conversion of string format, it is required just because the stream of characters is being sent. Okay, that needs to be converted into what is called as an object format, because everything is object oriented. That's why there is a typecasting required, and that I will store in the message that I want to print. Then I will simply print message received as MSG. Okay. So what is that I have done? I have done the steps like this. On the server side, I have called server socket with the socket number. On the client side, I have called socket with the IP address and the socket number with which I want to connect. Then once I have done that, on the server side, based on the socket, based on the server socket that is created, the object using the object of server socket, I will call the function called accept, which generates a socket ID or which generates a socket object. Now, I will decide upon whether the client is only sending the data or receiving as well as sending. And similarly on the server, I will decide upon whether the server is receiving only or it is sending as well as receiving. Based on that, the input and output streams are fixed. Okay, the objects of input and output streams are being created. Next task is client sending the data. So server receives that. When it is receiving, it has to use input streams object. When the client is sending, it should use the output stream object. And with reference to output stream object, it has to call the write function. Here on the server side, it has to call the input streams object, and it has to use the read function. Once this is done, I have printed the message received by the server. Okay. Now I will pose a question to you. You just imagine like this. There's a client, there's a server. Now the thing is happening like this. Client has sent a hello message to the server. Server will receive it. print it on the screen. And server sends back hi message to the client. Client receives it, prints it on the screen. How you will go ahead with this if you want to implement this?
Ma'am, can I?
Yes, go ahead.
Yes, ma'am. In the server side, we have to create the data output stream object as well.
Yes,
And similarly, after it reads the message from the client,
yes,
then it will be writing like d out dot right
okay,
hi. And in the client side, I can even create the data input stream object and do the same.
correct, correct. So according to that, I will just show you the program that I have written. Okay, just pay attention for the two-way server and two-way client. Have a look at the difference that is there. It's very small difference that is available. Okay, the first few steps remain the same. Okay, then apart from input stream, I have created one output stream as well. Okay, then what I have done, I have called read UTF because server is first listening to the client. Okay, whatever message that is received from the client, that I have printed. Okay, then what I have done, I have written hello client from the write UTF or D out or output stream of the server. I have written hello client. Then on the client side, definitely there will be two. 1 minute. Okay. On the client side, definitely there will be two parts, that is one output stream as well as input stream. First task is, since server is receiving, first client has to send. Okay, and once that is done, it has to patiently wait for the server to send its message to the client. So whatever message that has come, that will be stored here, and that I am displaying. And since I have talked about both of these may throw exceptions and the kind of exceptions, as Anand has covered, the kind of exceptions are merely IO exceptions. Okay, so I have written them in try catch block. Even if you want to avoid this try catch block, you can write catch block explicitly, okay, by writing it as IO exception. Okay, so simple two examples I have explained. Today's your task is, okay, your task for today is, you just have to have creation of client and server applications for the following, okay, using TCP. Can you take down the question? Please acknowledge. Can you take down the question? One of you acknowledge, please.
Yes, ma'am.
Okay, take down. Create a client server application which does the following, operations. Use TCP. Use TCP. Okay, for the first one, server sends a message. Server sends a message to a client. Server sends a message to a client asking for a positive integer, asking for a positive integer. Second one, client in turn sends a number and waits for server response. And waits for server's response. Third one, server receives the number sent by the client. Server receives the number sent by the client and processes for its equivalent factorial. Processes for its equivalent factorial and sends it back to client. The client, next step, fourth I think, the client then prints both the number as well as its factorial. The client then prints both the number as well as its factorial. Okay. Can anybody tell how the things have to be done? Just read out the things and explain it. Yeah.
Me.
Yeah, go ahead.
First, to create
I'm unable to hear you. Yes, Ankit, I'm unable to hear you.
am
Voice is breaking.
I audible now, ma'am?
Yes, now you are audible. Go ahead.
Okay. So create a client server application we have to create, ma'am. We are using TCP, which does the following operation. Firstly, server will send a queue message to a client.
Hmm?
After that, client in turn will send a number and will wait for the server's response.
Yeah.
After that, server receives the number which was sent by the client and it will calculate its factorial, equivalent factorial, and again send it back to the client.
Correct.
Now client will print both the
You
number
just tell
as
me
well
the
as the
steps.
factorial
See,
receipt.
you just tell me the steps. What should happen on client? What should happen on server? Fadafat.
Okay. Yeah. Firstly, like steps both client and server.
Both server and client must have input as well as output.
Yes, ma'am.
Okay. Yeah. Next.
Yeah. Means firstly the connection will get over, ma'am. After the server will send a queue message to the client asking for the number. After that, ma'am, client will send that number to the server, ma'am.
Hmm?
Now
So what
server will
function I have
calculate
to use? What function I have to use?
the ma'am, are you talking about input output stream?
Pardon?
Are you telling about that input and output stream, ma'am?
Yes. It is not input output. Input output stream both are required on both the ends.
Yes, ma'am. Yes, ma'am.
So when what
Send.
stream has to use? Okay, let me just take up because I'm left out with only 4 minutes. Okay.
Okay, ma'am.
See, you will create a server socket and accept. Okay, on the server side. On the client side, you will create a socket and with the ID that is being provided by the server. Now, I'll create data output stream as well as data input stream for both the ends, client as well as server. So, client first has to receive. It means what? The first task of client is it has to call read UTF because server is sending a message hello and enter a positive integer. Okay, so client will be in the listen mode at the initial stage. This will be my first step. Okay. Then on the server side, since client is receiving, first task of the server is to write it. What is that? What is that it has to write? It has to write enter a positive integer. So first task is to have dout dot write UTF. Okay. So once you write that enter a positive integer, the client would have received by using din.readUTF and the message will be displayed. System.out.println message. Then next client has to write. So dout.write will come afterwards. Okay. Dout.write of what is that? The number that you want to send. So you can read it from the user using scanner. That number which you have read, that number you can pass it to write. Okay. Then once that is done, on the server side, it should call read din.read because client has sent the number. So first it has written, now it has to call read and store it in a number. That number will definitely not be in integer format. It will be in the string format. So string format to integer format conversion, how do you do it? Integer.parseInt. After doing that, that number goes and sits in an integer variable. Then using the for loop, compute the factorial. The factorial that you have got after the for loop, that factorial has to be written by using write UTF. I hope you are understanding what I am explaining. Okay. When you use write with dout, the dout and write will be containing the factorial of the number. So on the client side, it should read by using din.read. And at that point in time, I don't require any conversion of string to integer because it is merely displaying. So directly you can go for type conversion of string and then print the display in the message. The factorial of n is so and so. This is how the things have to take care. Okay. I will give you 1 day time for this. Okay. When we come back to the next class, I want somebody to show me that program by sharing your screen. Okay. Take down one more example.